Doubly linked list. An introduction. In the realm of data structures, linked list stand as a fundamental building block of storing and managing collections of data. Among the various types of linked list, the doubly linked list stands out for its unique structure and versatility. Unlike singly linked list, which allows traversal in only one direction, doubly linked list provides bidirectional traversal, enabling efficient access to elements from either side. This presentation dives deep into the intricacies of doubly linked list, exploring their structures, traversal method, insertion and deletion operations, advantages, disadvantages, and the real-world applications. Understanding the structure of doubly linked list. At the heart of the doubly linked list lies the concept of nodes. Each node contains three components: the data element itself, a pointer to the preceding node, which is previous, and a pointer to the succeeding node, which is next. This interconnected structure forms a chain of nodes, which each node is linked to its neighbor on the both sides. The list is typically maintained with two pointers, a head pointer that points to the first node and the tail pointer that points to the last node. These pointers serve as entry points to traverse the list efficiently. Node structure. The fundamental building block of a doubly linked list is the node. Each node encapsulates a data element and two pointers, which is previous and next. In previous node, it points to the preceding node in the list. Next points to the succeeding node in the list. Head and tail pointers. The head pointers points to the first node in the list, while the tail pointers points to the last node. These pointers provide a convenient access points to the beginning and the end of the list. Traversal. The ability to traverse both forward and backward through the list using the next and the previous pointers distinguish a doubly linked list and form a singly linked list counterpart. Traversing a doubly linked list. Traversing a doubly linked list involves systematically visiting each node in the list. Due to its bidirectional nature, traversal can occur in both forward and backward directions. Forward traversal starts from the head pointer, iterating through the nodes using the next pointers until the end of the list is reached. Backward traversal, on the other hand, begins from the tail pointer, navigating through the list using the previous pointers. Forward traversal. Start at the head pointer and follow the next pointer until the end of the list is reached. Backward traversal. At the tail pointer, the or follows a previous pointer until the beginning of the list is reached out. Inserting nodes in the doubly linked list. Inserting a node in doubly linked list involves modifying the pointers of existing node to incorporate the new node into the list. The process varies depending on the position where new node needs to be inserted. There are three primary scenarios: insertion at the beginning, insertion at the end, and insertion at a specific position within the list. Each scenario requires careful pointer manipulation to maintain the integrity of the list. Insertion at the beginning. The new node becomes the head of the list. The next pointer of the node points to the original head, and the previous pointer of the original head is updated to point to the new node. Insertion at the end. The new node becomes the tail of the list. The previous pointer of the new node points to the original tail, and the next pointer of the original tail is updated to point to the new node. Insertion at a specific position. The new node is inserted between two existing nodes. The next pointer of the new node points to the node after the insertion point, and the previous pointer of the node points to the node before the insertion point. The previous pointer of the node after the insertion point is updated to point to the new node and the new pointer of the node before the insertion point is updated point to the next node. Deleting nodes from doubly linked list. Deleting a node from doubly linked list requires updating pointers to remove the node from the linked structure. The deletion process depends on the position of node being deleted. The three main scenarios include deleting the node, deleting the tail node, and deleting a node at a specific position within the list. Deletion of the head node. Update the head pointer to point on the next node in the list. The previous pointer of the next node is set to null. Deletion of tail node. Update the tail pointer to point the previous node in the list. The next pointer of the previous node is set to null. Deletion of node at a specific position. Update the next pointer of previous node to point to the node after the deleted node and the previous pointer of the node after the deleted node to point to the previous node. Advantages and disadvantages of doubly linked list. Doubly linked list offers a unique combination of advantages and disadvantages that makes suitable for specific use cases. Understanding these factors is crucial for choosing the appropriate data structure of your program. The main advantage and disadvantage of doubly linked list are bidirectional traversal, which allows in both forward and backward directions, enabling efficient access to elements either end of the list. The disadvantages of doubly linked list is increased memory overhead. Each node in the doubly linked list requires two pointers, resulting in larger memory footprint compared to singly linked lists. Real world applications of doubly linked lists. Doubly linked lists find practical applications in various domains where efficient data manipulation and bidirectional access are essential. This application demonstrates the power of versatility of this data structure. Some of the prominent use cases include web browsing history, undo and redo functionality, music players, and game development. Key concepts and takeaways. In summary, doubly linked lists are versatile data structure that offers bidirectional, traversal, efficient insertion and deletion operations and a wide range of applications. While the complexity may slightly higher than single linked list, the advantages in handling dynamic data manipulation and providing direct access to both ends of the list make them valuable in various domains. Node structure. Each node in doubly linked list contains three components: the data element, previous pointer, and the next pointer. Head and tail pointers. The head pointer points to the first node while the tail pointer points to the last node. Traversal. Traversing a doubly linked list can be done in both forward and backward directions using the next and the previous pointers. Insertion and deletion. Inserting and deleting node involves updating pointer to maintain the integrity of the list. There are also advantages in handling data manipulation and providing direct access to both ends of the list, which make them valuable in various domains. Thank you.